Today we're going to pick up where we left off yesterday and start discussing how to go and multiply rational expressions. So the other day we started by looking at how we define rational expressions, how we determine what the excluded values are, and then how to go and simplify them. Well, today we're doing multiplication. The good news is it actually isn't anything new, okay? But what we're going to do is just take a look at a couple of examples, and that'll be it. So today will be short and sweet to give you guys more time to go practice this, because yeah, that's important. Okay, so again, we're kind of continuing on with the note handout that you got the other day. So that's why we're starting off with example 4, because we've already covered examples 1, 2, and 3. Okay, so if we're multiplying rational expressions, it's going to look a lot like what you did in maybe 5th, 6th, or 7th grade when you did operations with rational numbers. So you started off doing multiplication with those operations. Okay, so hopefully you remember that when we're doing problems like just say 3 over 20 times 12 over 9, what we're really saying is this isn't two rational expressions, the first being 3 over 20 and the second being 12 over 9 being multiplied together, but it's really just one rational expression, okay? So it's really just 3 times 12 over 20 times 9, okay? So that's what I mean when I said it's not really anything new, because we're still ultimately just simplifying a rational expression, okay? This is the way that I prefer to go and teach this, because this is the way that I think about this. You may see some other people that'll do like cross cancel. I don't really like that. Again, I hate the word cancel. It's mathematically inaccurate. It means nothing, and it's more confusing than it is useful. So instead, we're just going to use properties of rational expressions and say that we can write it this way. Then we could go and write it down in its prime or close enough to prime factorization. So 3 is already kind of prime, and then 12, we could write that as 3 times 4. So this is still 3 times 12. Down in the denominator, I'm going to try and match as many of those numbers as I can, okay? Can I get a 4 out of 20? Well, sure. 4 times 5 is 20. And then how can I make a 9? Maybe try and use some 3's? Sure. 9 is the same thing as 3 times 3. So this is 20 times 9. Then I can start saying 3 over 3 is 1. 4 over 4 is 1. This 3 over this 3 is an additional 1. So when all is said and done, I only have 1 in the numerator and then 5 in the denominator. Okay? Could I have gone through and actually multiplied that out and gotten, well, 3 times 12 is 36, and 20 times 9 is what, 180, and then 36 is 1/5 of 180? Yeah, you could have done that. But the reason I don't like doing that is A, bigger numbers are kind of bad. We're really trying to go through and factor, especially since we're going to be talking about factoring these types of polynomials here. But I also don't like it because you guys just try and do it in a calculator, and you can't do that when there's variables involved, okay? So let's just keep in mind that even if you're multiplying 2 or 3 or 4 rational expressions together, it's really just one big rational expression that's been partially factored already. So let's go take a look at the two examples real quick. So for the first one, we see that we've got a y minus 5 over 3y squared minus 3y times 2y squared over y squared minus 6y plus 5. Now, before we even get started, I'm going to go ahead and throw you guys a bit of a bone, okay? All of these have to be simplifiable in some way, shape, or form. So look at the opposite side and the opposite place, and that's probably going to be a hint. So I'm looking at this y minus 5 and the first rational, so I'm going to look at the second one, but instead of looking at the numerator, I'm going to look at the denominator. Y minus 5 is probably going to be a factor of this down here, because otherwise I wouldn't have anything that I could eliminate, okay? 2y squared and 3y squared minus 3y, well, this is a monomial. There's probably a monomial term that I can go through and eliminate, all right? But first, I'm going to go and just write it all out as a single rational. So I'm going to do parentheses because that makes it easier to organize. So I have y minus 5, and then that's getting multiplied by a 2y squared Then down in the denominator, I have a 3y squared minus 3y, and that's getting multiplied by a y squared minus 6y plus 5. Okay, so now I'm going to start trying to factor what I can factor. Up in the numerator, I can't really factor anything out of the y minus 5, so that's just going to stay y minus 5. Okay, in the denominator, I've got a GCF here. I could take out a 3y. So I'm going to take out a 3y, and I'm left with a, what, y minus 1? Because 3y times y is 3y squared, 3y times negative 1 is negative 3y. Okay, so do I have like a 3y or a y minus 1 I could take out of this? Well, I don't have a 3y, but I have just like a regular y. So I could write this as like y and then times 2y, because that's the same thing as 2y squared, right? Okay, so then over here, y squared minus 6y plus 5, well, that's a quadratic trinomial with a leading coefficient of 1. So are there factors of a positive 5 that add up to a negative 6 that probably have a negative 5 in there? Yeah, it's going to be y minus 5 and y minus 1. So y minus 5 and y minus 1. Okay, if I can write it where y'all can see it close enough. Okay, so now I can start looking and saying, well, what do I have that are the same factor in the numerator as the denominator? Well, I have a y minus 5 in the numerator. I have a y minus 5 in the denominator. Those reduce to 1. I have a single y in the numerator. I have this y in the denominator that is part of 3y, but I could write it as y times 3. So I can go ahead and eliminate that y. Do I have any 2's or y's? Well, that's 3. That's not going to work. That's y minus 1. Not going to work. Y minus 1 again. That's not going to work. So I've effectively now gone through and reduced everything that I possibly can. So the final simplification is going to mean that it's just 2y in the numerator, and then I have a 3 times y minus 1, but I have 2 of them, so I'm going to write it as y minus 1 squared. Okay, so I'm going to go and drag this over so it doesn't get in the way of our next problem. But what we've done is we've taken a multiplication problem and said, well, it's really going to be a single rational where the numerators have been multiplied together and the denominators have been multiplied together. Then I'm going to go through and factor as much as I can, try and do some prime factorizations when it's possible so that I can eliminate these like factors in numerator and denominator by reducing them to 1. Then I can use the identity property where 1 times anything is itself. All right, so let's go take a look at the second one. So in number 2 here, it doesn't look like we have two rational expressions, but we should all recognize that we can always write anything as a rational expression by just putting it over 1. So doing what I did before, I'm going to say that this is going to factor into a 2x plus 1 times 2x minus 3. We're just multiplying the numerators together here. And then the denominator is just going to be, well, 2x squared minus x minus 3. Okay, times 1, so identity property. Now, we're trying to simplify this. So I'm going to look up at the numerator and think, I'm going to guess one of these two is probably one of the factors in the denominator. Otherwise, it wouldn't simplify. But let's go and see if we can remember how to factor a quadratic trinomial with a leading coefficient that's greater than 1. So for this one, I'm going to choose to do split the middle. So I'm going to say 2 times negative 3 is negative 6. Factors of negative 6 that add up to negative 1 would be like negative 3 and positive 2. So I could go and say that this is 2x squared minus 3x plus 2x minus 3. Then I could go and factor by grouping. So I could take an x out here and say this is 2x minus 3. I could take a plus 1 out here and get a 2x minus 3. So that's going to tell me that I can rewrite this as numerator still 2x plus 1 times 2x minus 3. But the denominator can now be written as x plus 1 times 2x minus 3. And then, well, looky what's cooking. Okay, we've got 2x minus 3 as a factor. Even though it's a binomial, it's a factor because the whole frickin' thing's being multiplied here. And this 2x minus 3 is also a factor because its entire binomial is getting multiplied by this x minus 1. So guess what these all turn into? 1. Yay, fun, letters, numbers, whatever they are, who cares, okay? So this becomes just 1, and all that's left over is this 2x plus 1 over x plus 1. And that, ladies and gentlemen, is the answer, unless you're thinking like an idiot. And if you're thinking like an idiot, you go, well, 1 over 1, them just cancel out. X over x, them just cancel out. The answer's 2. But it's not. It's 2x plus 1 over x plus 1. This plus 1, not a factor. Okay? It's a term. We can't eliminate terms. We can only eliminate factors. Factors are connected exclusively by multiplication. This is connected by a plus sign, which is addition. No touchy. Okay? So this is just 2x plus 1 over x plus 1. Now, the only other thing I'm going to say is you'll notice that for the two that I worked out today, we did not go through and include any excluded values. And that's really just because the directions for today just said to simplify. If it said simplify and identify the excluded values, then I'd have to go look at the original rational expression and set each denominator factor that had a variable equal to 0 to get a list of the excluded values. So over here, you'd have 2 excluded values and then 2 excluded values, so you'd have a total of 4. Over in this problem, you just have 2 excluded values that would come from those 2 factors being equivalent to 0. Okay? So if it says to go through and do excluded values, do it. If it just says to simplify, well, then that's all you got to do. All right? So again, to kind of recap, every time that we're doing multiplication with rational expressions, it's really just more simplifying. It's just been partially factored, kind of. Okay? So that's what this multiplication is, because how are these connected? Multiplication. So, haha, they must be factors. All right? Try not to do the like cross cancel thing that maybe a middle school teacher taught you that makes me want to throat punch them. But anyway, it's way better to go through and just write it out in factored form and then realize that like factors are being reduced to 1 and things don't just magically disappear in algebra, right? So you should have plenty of time to go through and get lots and lots of practice in with simplifying rational expressions using multiplication.